find your X? Well, not here, because this is Miss Miller's math show. Well, I guess you could find your X, but still.
That was very good. Oh, you guys remember that still. That's awesome. Oh, it's just really quiet. That's the problem. Okay, that's great. What's that?
We only listen to it 4 times a day.
I know, right? We should have you guys do that. All right, here we go. So, here we are. I'm getting some frowns. People are looking at this and they are not happy.
No, I think it's just
based on what they see. Oh, the music? I know. You guys want to do it now?
Yeah.
Go for it. Woo! You did do that.
No, I didn't.
Yeah, I think that's just a ploy to be able to be loud again. All right, here we go. So, here we are. Third order systems of equations. So far, all of the systems of equations that we have done have been second order, which means there have been 2 missing variables. So let me put an example of what we have done so far up here so we can kind of refer to it.
Good morning, Miss Thomas Charter. This is Christian Wheeler and Earl Coe with your
We'll take a
daily
pause.
bulletin. All right, hey Charter.
Remember the good old days. X minus y equals 2. Oops, no. X plus y equals 2. X minus y equals 10. I can read. Okay, so can somebody tell me how we would go about solving this? Rosler.
You could get rid of the y's.
That's good. So you add them straight down, so you get rid of the y's and you get what?
You would get x, or 2x equals 12.
Good. And then what?
Then you would divide by 2 on 1, and you would get x equals 6.
Excellent. And then can somebody else tell me after we've solved for one variable what we would do next? Inigas. Good, perfect. You plug the x into one of the equations above. I'm going to stop there because we now want to take this same concept and apply it to third order systems, okay? So, here, maybe we should do a stretch again.
Yeah.
Okay, so here's the deal with these. The very, very first thing that you want to do is make sure that you have copied the problem down exactly how it is on here onto your paper. Everybody do that right now, because if you get 1 plus or 1 minus wrong, the whole thing is messed up. And that's,
It takes a while to get it.
yeah. It says x plus y minus z equals 2, and then it says x minus y minus 2z equals 2, and then 2x plus 3y plus z equals 9. All right. I have had students who have come in during lunch, very frustrated, looking like they want to pull their hair out and kill me all at the same time, because they're getting all these numbers that are just funky, they don't make sense, and it's because they did one of the positives or negatives wrong. Okay, so just that's huge. The second thing, be organized. So those of us, this is a good organization lesson too. If you're disorganized, some of us are throwing down our stuff. We can't go on because we can't be organized. Practice makes perfect. Okay, we're throwing up our hands. Okay, so here's how we're going to do this. Be organized. We're going to label our equations, 1, 2, and 3. 1, 2, and 3. Start with the one at the top. That's 1. Kind of makes sense. Then the second one is 2. Okay, so here's where we're going with this. We're starting out, clap if you see that we're starting out with 3 equations here. Clap if you see that. That better be all of us. Okay, then we're going down from 3 equations with 3 unknowns to 2 equations with 2 unknowns. Then from 2 equations with 2 unknowns to 1 equation, 1 unknown. We solve that. When we solve for one of the letters or variables, then we plug it back into one of the 2 equations, and then we take those 2 and plug it back into 3. So think of like a funnel. We're starting out with 3 and funneling our way down and then funneling our way back up. Okay? So here we go. This is how I want you guys to approach these problems. If you are looking at this, the very first thing that Rosler said was to cancel out the y's. if you look at combining any two equations here, does anybody see anything right off the bat that would cancel out? Crawford.
The equation 1 and 2.
Excellent. Give it up for Crawford. Upset. Okay, equation 1 and 2, I'm assuming you were looking at the y's, yes? Cool. Okay. Barry. 1 and 3. Good. Negative z and positive z. Everybody give it up for Barry. Hey. All right, so only because Crawford posed 1 and 2 together first, let's do those first, okay? And this is going to set the tone for the whole entire problem, okay? This is the organization piece. So I'm actually just going to copy down equations 1 and 2 right here. Higginson, what's up? You'll see. We're going to kind of go through it. Right now we start, so the 3 here represents the fact that we start out with 3 equations. Okay, we're going to get those 3 equations down to 2 equations. And then we're going to get that 2 equations to 1 equation. So you'll see how it works in just a little bit. 2. Okay, so can somebody tell me when we add these 2 equations together what we end up with? Crawford?
2z and negative 3z.
2x minus 3z equals?
Yeah, sorry. I was
You're good. What's 2 plus 2?
Oh, 4.
Good. All right, everybody give it up for Crawford. All right. Now, here is where we want to go next. So Barry recognized that if I combine equations 1 and 3, the z's cancel out. And that's where a lot of people would go next. But that's not where you actually want to go. Notice that we wanted to cancel the y's out first here. We want to find another 2 equations that we can combine together and cancel y's out. Okay, we might have to multiply one of the equations by something, but that's where we're going. So, in other words, if, again, I'm looking back at the y's, specifically the y's, again, we might have to multiply one whole equation by a number to get the y's to cancel out again, but can anyone make a suggestion about 2 different equations that we can combine to get y's to cancel out? Ordona? Ordonia? Which one? 1 and 3, good. 1 and 3 would work. Did Martinez? 2 and 3 would work. I am going to say that I prefer 2 and 3. Why do I prefer 2 and 3? There's already a negative on the y there, so we don't have to worry about the negative. Okay, so if we combine equations 2 and 3, what am I going to have to multiply equation 2 by to get those y's to cancel out? A 3, right? Why 3 again? Because then it'll cancel out the y's. If we want to get these to cancel out, we have to have positive 3y and negative 3y here, correct? Okay, so we're going to multiply equation 2 by the number 3, all of it, and then we're also going to combine it with equation 3. Okay, so can somebody multiply the number 3 by all of these pieces in equation 2 for me? McDonald?
3x minus 3y minus 6.
Good. Equals? Perfect. Give it up for McDonald and Martinez and Ordonia and Suspila, everybody who participated. Okay, cool. And then we're just combining it with equation 3, so I'm going to put that down here underneath. Z equals 9. All right. Can somebody tell me when I add these equations together what I end up with? So I'm adding 3x minus 3y minus 6z equals 6 to 2x plus 3y plus z equals 9. What happens here? Ramos?
5x plus 5z equals 15.
All right, everybody give it up for Ramos.
Sorry, clap.
All right, 5x minus 5z equals 15. Okay, so we just took the 3 equations and we got them down to 2. Can anyone take a guess at what we're going to do with these 2 equations? Iniguez? Go ahead.
Put the 2 equations that we got.
Exactly. So she's saying you take the 2 equations we got and do this. Put them on top of each other. Give it up for Iniguez. Yes. Okay. We're going to give it up for Iniguez. All right. So that becomes, now this is the 2 equations piece. 2 equations with 2 unknowns. So we put 2x minus 3z equals 4, right here, and 5x minus 5z equals 15, right there. Okay, now we're back to everything that we've been doing before. So, suggestions. What do I do here? We've been doing, this is something that we did all along. Ordonia. Good. Try and get either the x's to be the same number or the z's. Give it up for Ordonia. All right, he is giving it up for himself. All right. Okay. Now, what next? So if we're gonna, do you guys want to get the x's to cancel out or the z's? We have a difference of opinion. Okay, the x's, that works. So, what do I have to multiply? -5 by the top, and then 2 by the bottom. Was that you, Barry? Cool, everybody give it up for Barry. -5 and 2. Can someone explain to me why -5 and 2? She's absolutely right. Rosler.
Well, I'm not really sure why -5.
Uh-huh.
Oh, wait. No, they go. No, but the 5 and 2 are the terms on the x's of both equations.
Excellent. Give it up. Go ahead.
Because it's not a negative.
Good. Okay. So what he said was, they're the numbers that are in the opposite equation. Can someone piece together the negative part of it? Why does it have to be a negative? Ramos?
So they can cancel each other out.
They can cancel each other out. All right. Give it up for Rosler and Ramos. Ooh, you guys can fight crying together. Okay. So somebody tell me, can someone multiply the -5 through on the top for me? Casho?
-10x plus 15z
Was -20. All right, give it up for Casho. All right, how about the bottom one? Multiplying that 2 through. Babcock? Hopkins.
10x minus 10z equals 30.
10x minus 10z equals 30. Give it up for Hopkins. All right. And now, if we add them together, can somebody tell me what we end up with? Here. Anderson.
We end up with -5z. We end up with 5z
Good?
equals 10.
10. All right, cool. Give it up for Anderson. Okay? Last step to solve this for z. Mora? Excellent. Everybody give it up for Mora. All right. Dude, that was the weakest round of applause ever. All right. So now, if we're looking at our timeline up here, we just found our one equation and we've solved for the one that we had. What this means is, if we're going back to 2, we're taking that, what we just got, and plugging it back into one of the 2 equations that we just combined together. Okay? Either of them. Doesn't matter which. So somebody pick one for me. The top one? Okay? So the 2x minus 3z equals 4. Oop, and we're fading out. Okay. So plug it into the 2x minus 3z equals 4. Plugging it in for z. And by the way, if you all are getting fractions on these, Garcia, you paying attention? Okay, shh. So, if you get fractions on these, something went very wrong somewhere. That is just cruel and unusual punishment to have fractions in these massive problems. What's up, Garcia? No. Let's have a round of applause for that. No fractions. That was good. Yes. All right, I got to switch papers, you guys. So we've got, let's see, 2x minus 6 equals 4. Okay, can somebody solve this for me? 2x minus 6 equals 4. How do I solve it? Mendez. Good? Good, divide by 2, so x equals how much? 5. All right, give it up for Mendez. Yay. Okay, so here's where we are in our timeline. We went from 3 to 2 to 1. We now have 2 variables. We have x and z, And now we want to take those two x and z's and plug them where? One of the equations that has 3 variables in it. So back to the very beginning. Okay, Casho wants to plug it into number 1. Cool, let's plug it into 1. Y minus z equals 2. So again, we found that, where are we here? We found that x was 5. We're looking for y, and we found that z was 2. So, somebody finish this problem out for me. We are at the very end. Rosler.
Alright, so you can do like 5 plus y. Oh, very good. Sorry.
So it's 5 minus 2.
Alright, so you're going to want to get rid of probably your 2, so you do like plus 2 to each side.
Okay. Let's combine it first. What's 5 minus 2?
Or minus 2 is
Good. 3 plus y equals 2, and then...
subtract 3 and subtract 3, and you get y equals -1.
All right, everybody give it up for Rosler. Cool. Okay. The last step is we want to put it in coordinate form. Remember, it was always x comma y. Well, now it's x comma y comma z at the end. So can someone tell me what the final coordinate answer is here? Hopkins.
5, -1, 2.
5, -1, 2. Cool. Everybody give it up for Hopkins. Questions. Questions. Anderson, do you disagree with something?
No, it was just
Ah.
doing something.
Okay, nice. All right, any questions?
No.
Anderson?
Will we ever need to wrap this in the future?
If you go up to multivariable calculus, yes. Maybe pre-calculus. I don't remember if you get into 3D stuff in pre-calculus.
Okay, so not.
Does that have to do with going to calculus?
This stuff, you get to multivariable stuff, yes. All right, Rudolph.
Will we be having any more exams?
We will not.
Yay.
Oh, a round of applause for that. All right, so your homework is page 178, numbers 1 to 5, odd. All right. I'm going to play our song that did not play to let us get into our lovely homework time. Okay, you guys, send us off, will you?